Okay, so this problem says two parallel conducting plates, each of cross-sectional area 400 centimeters squares are 2 centimeters apart and uncharged. So the area is 400 centimeters square, and of course this is not to scale. The separation between them is 2 centimeters. Now what you do is you take a trillion electrons and transfer from one plate to the other. So we'll take electrons from here and transfer to this plate. They were both neutral, so now this becomes positively charged, or we'll take electrons from here and transfer there. So this becomes positively charged. And when two parallel plates are facing each other, it turns out that the charge will be on this surface, on the inner surface, to ensure that the electric field inside the conductors is zero and all that kind of stuff. Okay. Okay, so again, let me make sure you guys understand this. So if you have two parallel plates like this, okay, so you'll do a capacitor. All the charge is residing on this surface. There's no charge on this surface. So if this was a thick plate. Okay. All right. So again, so let's say this is a metal plate, and this is, the table is a metal plate. We take charges from here and put it there. All the charges will be on this inner surface. So electrons are transferred from one plate to the other. What are the charges on each plate? The electric field between the plates. So the charge on each plate, of course, is n times the charge of the electron, and so you have a trillion electrons, and the charge of each electron is 10 minus 19 coulomb. So 0.16, oops. Hello? Hi. I'm in the middle of the lecture. Let me call you back in 2 minutes. Okay, go ahead. All right. 10 minus 7, and so this works out to 10 minus 6 coulombs, 0.16 microcoulombs. All right. Now, part B, we want to find the electric field due to these plates. For part B, let me remind you, you guys can check on your notes. On a conductor, all the charge resides on the surface. From a conductor close to a conductor, all the electric field is perpendicular to the surface, and this electric field is the surface charge density divided by epsilon naught. Okay, you can check your notes. So we'll use that for finding the electric field between the plates. Now, so what I'll do is let me grab this diagram. So, okay. So everybody here has a question? So that's a point of confusion. So let's say you take a sheet of a plastic sheet. and you spray it evenly with charge, this this produces an electric field, the sigma by 2 epsilon naught. Okay. On a conductor, all the charge is residing on the surface. And when they give you sigma, they give you this sigma. And this sigma is not producing any electric field here. It's only producing it here. So this electric field is twice that. You can think of this, the field on the left got brought out to the side, to this side. Okay. All right. Yep. I'm sorry?
1.6 times 10 to the negative 19 is n, right?
No, n is a trillion electrons. This E is, that's the charge of it, a single electron. Yeah, that's a constant. Yes. It's in the back of the book.
It's just a constant. It's like,
Oh no, it was measured. It remember Mr. Millikan measured. Well, Mr. Millikan measured the charge, the fundamental charge, but yeah. You have a phone? Google the electron charge. What happened? I'd copied that stuff. The clipboard forgets stuff?
It shouldn't.
I know, it shouldn't. Oh, it's easier to just draw a new one. Okay, so this sigma is Q by A. Q is 0.16 microcoulombs. Remember, 0.1 microcoulomb is spread over this face. And the area of this face is, of course, 400 centimeters squared. So that'll be sigma. Okay. And we just saw that this will produce an electric field sigma by epsilon naught. The negative charge will also produce an electric field sigma by epsilon naught. So the two fields add up, and so the net field is produced from the positive charge plus the electric field, okay? And so this is sigma by epsilon naught plus sigma by epsilon naught. Okay. So that's the electric field between the plates, and that's 2Q over. And let's, I guess we can calculate it. Q is 0.16 into 10 minus 6 coulombs. Epsilon naught is 8.85 into 10 minus 12. What are the units? area is 400 centimeters square. Okay. So this, let's take care of powers of 10. This is 10 minus 8. When it comes there, it becomes 10 plus 2, 6. So this whole thing becomes 2 into 16 divided by 8.85 into 400. And it should work out to Newton per Coulomb. Okay. So this is equal to so that's the electric field between the plates. Okay.